So 15.9, we're going to do something called a reflection. It's like the reflection in a mirror. So we have a pentagon there, a five-sided polygon called ABCDE, and it's going to be translated 9 units right and 2 units down. Find the new coordinates. So 9 units to the right and 2 units down. So A should end up at 0, 3. Let's see if that's right. Right, well, from -9 to 9 gets you to 0 for sure. And then we're going 3 down. 1, 2, 3. Oops. I was at 5 and I went down, down 2. It says down 2 units. So yes, I end up at 3. There's where A prime is. And then B, we're going to add, what is -6.5 plus 9? That's sort of interesting. We're going to end up at 4 for B, right? We're going to be at 4. But what is -6.5? Well, it's 6.5 back to the y-axis, 7.5, 8.5, 9, right? Trailing 9 units to the right. So 6.5. Right, so then we need 9, we need another half. So that's 6.5, 7.5, 8.5, 9 is this half right there. So we should end up at where? At down here, right there, which is at 2.5, 4. Right, -6.5 plus 9 is 2. Or I guess since it was a decimal, I'll make it a decimal. 2.54. And then C, we're going to add 9. We should end up at 5, and then subtract 2, 5, 3. 5, 3. Yeah, and that looks correct, does it not? And then E, we end up at 4, positive 1. 3 minus 2, 4, 1. That's D prime, C prime, B prime. And last but not least, E prime must be right there. Again, I'm not the neatest. It says it's at 1, 1. Is that correct? We add 9, subtract 2. Yeah, we're at 1, 1. So there's the tricky part, though. -6.5 plus 9 is 2.5. All right, so this is a reflection. Well, now when we reflect something, you have to have reflected over something. So if a reflection is a mirror image, but another way to think of it is like flipping a pancake. I took this heart and I flipped it over the x-axis. So we're going to be doing reflections over the x-axis or over the y-axis. So you have to read each problem. And I didn't draw this perfectly because when you reflect something, it should be the exact same distance from whatever you flip it over. So if I reflect it over the x-axis, this tip of the heart should be exactly in the same spot on the other side. So let's do this. So it says reflect F across the y-axis. So if I said x-axis would be going down here, okay, but I said y-axis. It's not always the closest one, so you have to read it. So notice, this is 1 unit away, so you flip it over to the other side 1 unit away. Now here's the key to this one. This one is at 6, 5. And we're going to flip this over to -6, 5. Right? So, and notice it doesn't, make sure it is not twisted. Make sure you could take F, flip it like a pancake, and it would land right on F prime. That's what a reflection looks like. So we're going to reflect G across the y-axis. We're just going the other way. So G is 2 spaces away. So this front edge of the trapezoid G is going to go there. The back edge is at -5. So the back edge here will be at +5. And that's what the reflection of G looks like across the y-axis. So we're going to reflect H here across the x-axis, across this. We're going to flip it like a pancake over the x-axis, and it's got to be the exact same distance away, which is 1. So the key vertex is right there. That one's at 5, so we're going down to -5 here. We're going to draw the exact same shape flipped over. and that's h prime. We've reflected h across the x-axis. Now finally we're going to do one, we're going to reflect j across the x-axis. Right? It's right near the y-axis, but that's not where we're going. We're going to cross the x-axis. We're going over this. So this front edge is at -4. We're going up to +4. This back edge is at -8. We're going up to +8. And we're going to draw the exact same figure up here. And that's our j prime. That is j reflected across the x-axis. If you flip j over, it'll land right on top of j prime. So, to reflect an object across the x-axis, the y-coordinate changes to its opposite. Well, let's see if that's true. So you would write this as k prime goes to 4, -6, L prime goes to 2, -3, and M prime goes to 6, -3. Let's see if that's true. We're going to reflect KLM over the x-axis. So when you go over the x-axis, y becomes its opposite. So we're at 3, and we're going to go down to -3. There's the opposite part. This is at 6, that goes to -6. And so there's M prime, right? It's the mirror image, it's right, it doesn't twist. Right? So this was at 6, 3, and then this, whoops, 6, that's 6, +3, and this is 6, -3. That's this one right there. And so on. L prime is right there. Went from 2, 3 to 2, -3. And there's K prime. Went from 4, 6 to 4, -6. So when we flip across X, the y-axis, the y-coordinate becomes its opposite. So what happens when we go across Y? Well, let's see. Oh, we're not there yet. We're going to do one more across the x-axis. So we're going to do this one across the x-axis. So this one flips over there. It's at -1. It's going to go up to +1. This end is at 6, so it's at -6, so it's going up to +6. And so this is P prime, this is O prime, and this is N prime. So we're flipping across the x-axis, so the y-coordinate becomes its opposite. M prime is at 4, -4, 1. The y-coordinate becomes its opposite. And the y-coordinate becomes its opposite. And these, oh, and I should write the letters in, my fault. I went too fast. N prime should go there. Oh, well, that's why you have an eraser. O prime should go there. And P prime goes like that. All right, so now I suspect, now we're going across the y-axis and the x-coordinate becomes its opposite. So K prime will be -4, 6. L prime will be -2, 3. M prime equals -6, 3. Now this is easy to remember because you're doing the lesson right now, but you can always just figure out these patterns, but do one on a coordinate plane. Oh yeah, when I reflect over y, the x-coordinate becomes the opposite. When I reflect over x, the y-coordinate becomes the opposite. You can figure it out by doing one drawing because the rule is the rule. So K prime went from 4, 6 to -4, 6 over here. Right, that's our K prime. L went to -2, +3. There's L prime. Notice they flip. They're going to flip here because we're flipping the whole thing. M prime goes to -6, +3. Right? So this is a perfect example. If you write, so this is a reflection of KLM. Notice what happens. If I put this as L prime and this is M prime by mistake, I haven't reflected it. I've translated it then, right? Because then I've just moved M over 1, 2, 3, 4, 5, 6, 7, 8 to the left. And that would be interpreted as a translation. A reflection, you have to flip everything. And we reflected that across the y-axis. Let's do one more of these. We're reflecting across the y-axis, so the x-coordinate will become the opposite. The y-coordinate stays the same. And don't start changing both of them. And we can see this. We're going across the y-axis. We're going across this, and n is going to 4, -1. That's n prime. And O is going to 3, -6. and that is right there. That is our O prime. Notice we're flipping things, and then P prime is right there at 5, -6. And if you don't put O and you have to label O prime and P prime especially, because if you don't, we won't know if you did a translation or a reflection. So reflect NPQR across the y-axis, so that's across this, and determine the new coordinates. Okay, so we're at -5 there, so this must be at +5 here. And so that'll be P prime and that'll be Q prime. This back is at -8, so it's going to be at +8. Right, so you could make the drawing first and then just read the coordinates, or you could realize when you go across the y, it's the x coordinate that becomes the opposite. So 8, -2, 5, -3. Y coordinate stays the same. 5, -4, and 8, -5, right? And there they are. Is the new image congruent to the pre-image? Yes, just like with translations. The image does not change its size or shape. It's congruent. All right, so translations and reflections are both types of transformations. There are other types that we're going to go over for sure in 8th grade, if not before then. All right, so define each transformation as either a translation, a reflection, or a combination. So let's see this, S to T. So how did I get from S to T? Well, it's not flipped over. So it had to be a translation. And it was a translation of how much? Let's see. Right, it went 1, 2, and then we're at 6. 3, 4, 5, 6, 7, 8. 8 units, right. S to V. S to V, that's a reflection. And what was it? A reflection, you have to say what it was across the x-axis. Right, we flipped it over here. V to U. Now, what the heck happened with V to U? It's flipped over, but it's not just a reflection, because if it was just a reflection, it would be here. So it was a reflection, and sometimes you can do it in more, you can do this in more, this one can be done in a different order, but I'm going to say it was reflected across Y first. All right, let's see. First, it was reflected across the y-axis, and then it was translated. Right, this corner is now 2 units to the right. Now, could you have translated this 2 units to the left first and then reflected it? I didn't draw that properly. 2 units to the, yes, it would have been here, right? I could have said translate it 2 units left and then reflect it across the y-axis. But if I put the reflection first, the translation is to the right. If I put the translation first, it's to the left, and then we reflect that. Okay, so it can be a combination of the two. All right, so how did we get from A to B? All right, so it was a translation, right? Now, and because it's not, you can see C has got some reflection in it. We got from A to B strictly by translated, and it was 2 things, right? We went 1, 2, 3, 4, 5, 6, 7, 8 to the right, 8 units right, and then we went 1, 2, 3, 4, 5 units up. But it was all translation. B to C. Oh, I left more room than I thought. All right, so B to C. All right, let's see. If I take B and flip it over, will I land on C? Well, this front is at 6. This front lines up with this one. It does line up with it, and it's at 9 and -9. Yeah, so this is a reflection across the x-axis. And what's left? D to C. All right, so D to C is a combination. So what am I going to do? I'm going to move it. I'm going to translate it first. I'm going to translate it into translate was translated, and I'm going to move it 1, 2, 3. I'm going to move it right there, because once I move it there, then I can reflect it. So it's 3 units right, 3 units right, and then number 2, it's going to be a reflection across the y-axis. All right, reflect WZAB across the y-axis. Okay, so this is the y-axis. And determine the new coordinates. All right, so if you reflect it across y, right, the x coordinates are all going to become opposites. So 4, -6, 5, -9, 7, -9, 6, -6. And so this is at -4, this is at +4. So this is W prime. B is at -6, then we're going to be at +6. Z is at -5, it's going to be at +5. So here's Z prime, here's B prime. And so I'm intentionally doing some parallelograms because they tend to be the trickier ones. Yeah, if you flip WZAB, that's what it will look like on the other side of Y. Is line segment AB congruent to A prime B prime? Yes, everything is congruent. The angles are congruent. The sides are congruent. The shape is congruent. Parallel WZAB is reflected across the x-axis. That means the y coordinate becomes its opposite. So we're going to do W prime, Z prime, A prime, B prime. The y coordinate becomes its opposite. The x coordinate stays the same. You know, and you could always draw it. You could always make your own if you wanted to. All right. Good luck on the homework.